Here on M5-101, it says, in previous courses you explored how the volume of a pyramid is related to the volume of a prism. Let's explore how the volume of a cone is related to the volume of a cylinder. You can use the nets to investigate this relationship. So if you have not made your own shapes, you can watch the video of where I made them, kind of see how that's put together. They were not easy to make. So it says, number one says, use the nets provided at the end of the lesson to create models of the cylinder and cone. What is similar about the cone and cylinder formed from the nets? So when we look at those nets, they have the same height. They also have the same base. So if you kind of look at those circular bases, and I know they're kind of hard to tell here, but they are the same size. So they almost basically have all the same dimensions, height and that base. So you can kind of see how the volumes are going to be related, since the last lesson we learned that the volume of a cone is going to be that circular base times the height. So we need to figure out how is that different than the cone, because you can't do just base times height, because obviously they're different. So what do you think is true about these relationships? We know they're going to be related. So we know the calculation's somehow going to be similar. There's just might be something that we need to do to get to the volume of the cone. So number 2 says, fill the cone with birdseed, then pour the birdseed into the cylinder. Continue refilling the cone until you fill the cylinder with birdseed. So here I have the cylinder and cone that I've constructed from our workbook pages. Now something that we've noticed is the fact that the circles that make up the bases are the same size. So that's something that's very common between these, and the heights are also the same. So what we're going to figure out is basically what's the relationship between the volumes. So they recommended birdseed, which I interestingly actually have. You can use anything that's small that will fill up space. So if you have sand or small rocks or something like that, that would be fine. So basically I'm gonna see how many cones it takes to fill up the cylinder. So I'm gonna fill up our cone. So there's one cone. I'm gonna put it right into our cylinder. And wow, this is messy. Okay, so there's one. Here's two. Okay, and I can already see that it's pretty full. It's getting there. Like if I look from the side, it's almost like 2/3 full now. And here's another one. And there's 3. Now, I know that's not perfect. I still have a little bit left here, but obviously I've been spilling a lot. So what we actually just did is we proved that you can fit in the volume of 3 cones into a cylinder that shares those same dimensions. So as long as you have the same circle for the base, so basically the same radius or the same diameter and the same height, then you can take 3 of those cones and make up the cylinder, or vice versa, 1/3 of this cylinder will make up the cone. So here I've just poured 1/3 of the cylinder and that filled up the cone. So I could do that 3 times. So if you know the volume of one of these, you can find the volume of the other. So now that we've seen it done, how many cones of birdseed did it take to fill the cylinder? It took 3. And that's because the volume of a cone is 1/3 the volume of a cylinder.